exceptionally awesome with it, and some people aren't as much. So what do we really need to know? What's important for us to understand about statistics, or why are we even talking about that in translating evidence into practice?
It's a part of every study.
We use it to make assertions about it.
Okay. I want, so 3 people had responses. So you said.
It's part of every study that you read. I mean, statistic analysis is
Right.
part of research, so it's
Okay.
be able to decipher what's significant and what's not.
Okay. So you understand the findings, right? I'm just abbreviating what he said. So you can understand what the findings are for the research. What were you saying?
Oh, I definitely agree with Major Fraley. And in addition to that, it's how we make these assertions in clinical practice and really develop our decision making based on statistics. We have these opinions.
Okay. So he's saying it's also support for your decision making. So when you're given rationale, essentially you're saying, hey, I read the study and the statistics demonstrated correlation or causality, even, hopefully. That would be the strongest, right? Okay.
To make sure they're running the correct statistics for what they're doing.
Very, very important. So that if you're informed, if you're not informed, you're going to be like, wow, this is really cool research. I learned so much from this. If you use lidocaine blunt on patients when you do an induction, then you're never going to have a bronchospasm in a reactive airway patient. Well, what if they use the wrong statistics? What if they're telling you that there's a significant difference or significant finding, but they applied an incorrect statistic? You're going to falsely believe that this is good information and apply it to your practice when it really isn't demonstrating that at all. And you would think that in a peer-reviewed journal, something like that would not occur. Is that a correct assumption?
It should be.
It's not really. It should be. It should be, but it's not, because we can do statistical magic, right? You can lie with statistics anytime you want, especially if you have an uninformed audience. Only the informed audience is going to say, you know what, this is a low quality article. They're not looking at what they should be looking at. What were you going to say, Captain Richards?
Basically just said what I was going to say, that they can be manipulated to show whatever you really want to show.
Yep. Yep. It's magic. Okay, so here's an example. On my study, I'm looking for agreement. I'm looking for consensus in this mixed methodology study. Okay? In reality, the most appropriate statistic, I should have used a Krippendorff's alpha. Okay, that is the truest measurement of agreement, right? But almost nobody's ever heard of a Krippendorff's alpha except for statisticians. It's not commonly utilized, right? It is appropriate for agreement, but it's not commonly utilized. So my statistician said, look, intraclass correlation, Cronbach's alpha, because everybody knows what that is, and it's evaluating variance still, evaluating variance, right? Not necessarily, so I can see if I have convergence and divergence using an intraclass correlation, and because eventually one of my aims is to see if a tool needs to be developed, okay? Then I already have the data for the beginning stages of tool development. So intraclass correlation, Cronbach's alpha is, or not Cronbach's, I'm sorry, Cohen's alpha is what we utilize. Because if I try to publish with Krippendorff alpha, they're going to say, why did you use this remote, rarely known statistics? What are you trying to hide? Right? So my next, in the conclusion, what will I say?
The reason why you used it.
I'm going to discuss that in reality, a Cronbach's alpha would be more appropriate. Then I'm going to do another study comparing running those, the Cohen's alpha and the Krippendorf's alpha, do a comparison and demonstrate how well they correlate, and then call for in the future that it's done with Krippendorf's alpha. What's another reason I may not have used that Krippendorf's alpha, besides the fact that why is it so rare that people actually utilize it? I'm sorry?
The assumptions.
The assumptions, okay, so most of the data met the assumptions. What did you say?
Is it possibly like too complicated or too time consuming?
Yeah, it's too complicated and it's too time consuming. You can't run Krippendorf's alpha and SPSS. You can do it with our software. I didn't do anything in my research practicum with our software. I know what it is, but I'm not facile with our software. So that means I would have to manually run or put a formula that we used to be able to do Krippendorf's alpha in SPSS, but it's no longer available. I'd have to manually do that. Do you know how many data points I had? I started out with something like 263 responses that I had to thematically code and try to get down to something workable. So the burden, I just straight up don't have the time to do that. And the amount of error that I could introduce by trying to run it manually on every single item would skew the data in and of itself, right? So it wasn't practical. So those are things to look at. When you're setting up your study, you have to know what's commonly accepted, what is actually evaluating what you're driving at, what programs can do it, and do you have the resources to use that? So that's, again, why there's no perfect studies and why it's important to be an informed consumer. I'm not a statistician, so what does that mean? Why am I saying that? Well, yeah, when you're doing studies, if you're not a statistician, it's important to know your limitations. It's important to recruit the right people, to find the right people. And you can inform yourself all you want reading. If you don't have any practical experience with statistics, then it's only theoretical knowledge. You don't know the true application, right? Does that make sense? All right, so it's cool, but it can be intimidating, not exciting. So we just answered all this, right? We talked about being able to review in a rigorous and systematic way the quality of the articles, see if what you're reading is saying what they're purporting that they found, right? And you can find holes all the time. When you're looking at case reports, same thing, right? They're only talking about a case report, but if they're introducing articles as supporting evidence that didn't have appropriate statistics, then they're supporting a faulty hypothesis, right? Okay. And then with protocols and guidelines, you want to see if that is also supported with appropriate statistics in those studies. And does anybody know what recursive partitioning is? So it's kind of like correlation analysis, okay, when you're looking at correlations, but it's used a lot in medicine because it's set up, it's a statistic that is set up for if X and Y and Z, then the disease is most likely A, okay? So it's conjecture. It's trying to look at multiple variables that could be related to a specific disease, okay? So that would be good in very complex things like emergence delirium where there's probably more than one variable, okay? So if you see that, we're focusing on quantitative for statistics, right? It's quantitative data. Can you do something similar to quantitative statistics or qualitative data in statistics? You can quantify your qualitative data. That's what they do in a metasynthesis, right? But what are you going to do with that? Are you doing like a t-test or Pearson's R correlation, things like that? No, you're most likely using descriptive statistics, correct? So when I collated all of my different verbal responses, then really all I could report on is frequency, the distribution, right? And I put it on a vast scale, 0 to 100, but then I had to describe what the results were with that, because those numbers really don't reflect the qualitative statement. It's just a way of quantifying it so that the information makes sense to everybody, right? Okay, so we use that. That's what I just described, right? We use quantify. We try to quantify things so that we can succinctly present it in a way that people can categorize in their mind and make sense of something, right? So we're taking something and we're putting it into a numerical representation, right? So so that people can conceptualize it quickly. You're trying to confirm or disprove your hypothesis, and then you're trying to make it clear that you can come to a conclusion regarding that information, that data. It's no good if it's just a bunch of information scattered all over the paper and it's not categorized into anything, right? Otherwise, you can't compare things. You can't see if they look like they're related, okay? And then you can't predict anything. Nope. Are you guys familiar? Okay, that didn't turn out so hot, huh? I should change the color of the print in the yellow boxes. All right, I apologize. I know, I apologize. It'll be on my evaluation. All right, are you guys familiar with this? Like nominal, ordinal, you're familiar with it? And you remember which ones are parametric and non-parametric? Is this a good review?
Yes.
So the big thing, okay, so you'll see this a lot. Likert scales. People will call it Likert, but it's Likert. All right, I know that sounds crazy. Right? Okay, Likert. What kind of data is Likert? A Likert scale. It's ordinal. Yeah, and some people will push it to interval, but does it really represent the same distance between each item? No, that's a false assumption. But you will see statistically a lot of people apply interval type tests, quantitative parametric continuous statistical tests to Likert scales. You will see it over and over and over. I have at least 8 studies stating that that's what they use to analyze their Likert scale. Okay? And it is accepted practice. But in reality, you really do need to have a true difference in that interval to state what you're trying to state, that they're equidistant from each other. Okay? So what would be another way of evaluating that? If you need parametric data, not non-parametric. If you need parametric data, what would be a better scale to utilize when you're having people rate things? If you want continuous data, what could you guys use?
On a scale of 0 to 10, how much do you, that's the word that's hard. You want a continuous.
Yeah. So she's stating it though. If you happen to quantify something, you can do a visual analog scale with a drag and drop, a slider scale, right? And now all of these different survey platforms have those drag and drops. So You can have a 0 to 100 scale and say, rate the relevance of this concept to this phenomenon and have them drag it. There really is a difference between 0 and 1 and 1 and 2 and 2 and 3, and they have the same distance between them, right? Now, it's subjective on the participants' part because they're rating it by their sense, right? That's fairly reliable though, right? You guys do that with a VNRS, the Visual Numerical Rating Scale of Pain, right? I'm pretty good at telling you what in my life has been around a 9 out of 10 versus what my life feels like a 2 out of 10. So like my arthritis is probably like a 2 or 3 out of 10. When they fractured my rib for my thoracotomy, that was right around, probably a 9 out of 10 when my epidural wore off, my thoracic epidural wore off, and it was the first day post-op. So I think I can fairly reliably rate that. If I went back and did it again, it'd be pretty close, okay? So is that pretty clear? So it's important to understand what tests you need parametric data with and what tests you need non-parametric, and it's good to have a review of that. So if you guys have in your folder flow chart for selecting the appropriate hypothesis test, and I wish I could remember what book I got this from. I have to write my buddy, Jason McGuire, Commander McGuire, because he gave this to me. So it tells you in this box is what kind of data is it? Is it nominal, ordinal, or interval and ratio? What's the difference between interval and ratio?
Absolute 0.
Absolute 0. That 0 means something or it doesn't, right? Temperature, 0 doesn't really mean anything. It's not a true value, right? But then when you get into your ratio, the 0 is a real anchor, okay? So then it goes on, okay? You've got your data. What are you looking for? Are you looking for relationships between variables or groups? Is it a group? Yeah, then it's a paired observation. How many groups? Oh, repeated measures or paired sample t-test. It tells you what you should have. Okay, that's nice, right? Because we don't walk around. How many of you use statistics in your day, in your life every day? I mean, we do to some degree. We hear it on the news all the time, but we don't have all the facts, so we're not deciphering it. So most people aren't walking around knowing exactly what statistical test goes with what kinds of information. So this is a nice flow sheet. That's why I gave it to y'all, so that you can look at it. Yeah. It's a nice resource. When you're evaluating your articles, and you're like, wait a minute, I said that they're looking for a relationship, and there's more than 2 variables. Why are they doing a correlation instead of a regression? Right? Maybe they're doing a correlation instead of a regression because they didn't find a significance with the regression, and so they changed their stats to correlation to get a difference, to show significance. Do people do that? Yeah, because they don't get published unless they have. That's a motivation. Or they don't get funded. Or they don't make tenure. Or they don't get it. Or nobody wants them on their interdisciplinary research. There's politics and everything. Okay. So that's why we reviewed that data. So what if you have something that's supposed to be, I started jumping ahead. Okay, so then descriptive is for summarizing words mostly, like demographic material. That would be descriptive statistics, right? You present that in a table with descriptive statistics. And then when you want to start making inferential, you want to start making inferences and say, this most likely causes this, or this is correlated to that, or there was a difference from before education and after education. Then you have to start using inferential statistics, right? Because you're making assumptions about your data. So you guys remember descriptive, right? So you're looking at what's the central tendency? How often does something occur? What's the mean, mode, or median? Okay? And then those are the kinds of, so continuous data with median, right? You can use or mean. If you have a bimodal distribution, it's really more appropriate to use mode, right? Because your dispersion is not centralized. And then you look at your dispersion. So if you've got a standard of deviation of like 9, there's a lot of variation in your data, right? The group was not similar. You didn't have a bell-shaped curve. And that changes the meaningfulness of that information. So maybe in this situation, if you've got a wide dispersion, you have an abnormal curve, maybe some data that you thought was parametric, a parametric test no longer applies, correct? Because you're violating the assumptions of that statistic. That statistical test, you're not meeting the basic qualifications, so now you have to go to what? Your non-parametric alternative that would do the same. That would do the same test, right? And that flow sheet's good for that too, okay? So you're doing a t-test. You look at your histogram and you've got really bad kurtosis, or it's a bimodal distribution instead of a bell-shaped curve. Now what do you have to do instead of your t-test? If you don't remember, please don't even feel bad. Huh? Wilcoxon, right?
What is kurtosis?
Okay, so here. We'll talk, I think I have that next. Okay, I know I have it next. Yeah. So what are descriptive good for? Well, descriptive data, like if you have demographics, for example, what's that useful for? Why do you want to be able to understand descriptive statistics? Does it matter how many people had a PhD, how many people sampled had an ADN? It could alter the results, right? It's a point that's worth addressing. What if your sample population is 2-year-olds to 88-year-olds, and the majority of the people were 88, right? People need to know that information to adequately evaluate what you're stating, because there are different conditions in those two populations, right? Okay. And then we talked about, and then categorical data, descriptive statistics are good for presenting category. Yes, no, right? Do you have a graduate degree? Yes or no? Okay, that might change things up. Do you have this disease? Yes, no, right? Is it present or not? So that'd be the difference between, did you have nausea or not, versus how many times did they retch? Did they actually vomit? But then again, you're using words to describe retching and vomit, but you're quantifying the number of times, okay? Statistical assumptions aren't met by evaluating the distribution, then you have to start looking at maybe using descriptive statistics that the distribution wasn't appropriate instead of using inferential. You thought you were going to have inferential information, but because you violated the assumption, you didn't, your data violated the assumptions of the statistics. Now you can only describe what happened and not make an inference, because it's not a true representation of that population. That population is not fitting the curve of normality. So now you can't make an inference or an assumption or a prediction. You can only describe what you saw in your data, okay? That's the down and dirty of it. So here, when you're looking, you want to look at your histogram, okay? And one test of normality is that Kolmogorov-Smirnov test. Sounds like vodka to me, so I always remember it. I have underneath your slide in the note part, it tells you exactly what you need to look at, what demonstrates significance and what doesn't, okay? So when you're running when you're running your stats, you can click on that as one of your choices in SPSS for your descriptive statistics, and it'll give you that data. And you also just have it plot out a histogram. Visually look at your histogram and see what does it look like. This parametric assumption, if it's normal, this is what you want to use for like a t-test, or if you're looking at analysis of variations. Okay? If the normality is met, then you stay with parametric. If it's not, then you have to shift to non-parametric. And that's where that little cheat sheet I give you is nice. I didn't answer your question. Okay? Yeah, so if it's symmetric, it's like that funnel plot in Biddle's chapter. Unbiased literature search, you want it symmetrical on both sides, right? Biased, it's not. If you've got skew, if it's all hanging to the right or the left, then that's demonstrating something different than a bell-shaped curve, right? And then it's not normally distributed. So if it's skewed, then you have to look at non-parametric options. If it's peaked, really highly peaked, everybody's clustered really tight versus spread out. Really, the big concern is if you have a really flat distribution, then that means you've got some serious outliers, right? Your population that's represented is very different. You don't have homogeneity, okay? You got a really peaked kurtosis, you've got homogeneity in your results, okay? And you can't necessarily say that you don't have homogeneity in your population, but you don't have it if it's flat in your results, in your data, okay? It's not alike, it's different. You've got big outliers. And there are things you can do with statistics to throw out your outliers as well. And so what's important is if you do something like that, or you remove the outliers, then you have to present that data. Like say, for example, interclass correlation, right? I have a bell-shaped curve, a normal distribution, if I throw out these three people that didn't respond like everybody else. What I have to present in my data then is what? Right, what it was before and how many had to be excluded to get to where I am now. If I had 15 participants, and in order for me to get a normal distribution, I had to exclude 8 responses. That says something completely different than if I had to exclude 1. If there was one egg that was not like the others, is completely different than if more than half of my population varied, right? All right. So, parametric is considered to be more robust. You don't need to have as large a sample to draw the same conclusion, okay? And the downside is there are a lot more assumptions that have to be met in order to utilize it, correct? So, why is this important? Parametric. You guys see this in your benchmark. The specific, fewer data for conclusion. Why is that important in research? Especially bench science with money. Yeah. Resources, money, right? It's costly. It's hard to get permission to kill something, right? So if you're going to kill something in the name of science, especially something that's known to be intelligent like a pig versus a rat, you better be able to demonstrate that your study was powered appropriately, and you better be able to get as much data as possible out of that one animal, right? And you need to be able to make a real conclusion about it. So you need to use parametric tests, because you can't really afford to kill 100 pigs. And you probably can't afford to buy 100 pigs, right? And all the hours of research in the lab working with 100 pigs, okay? Cool. So parametric You have to have continuous data. You need normal distribution, you need equal variance, and you need a standard of deviation that's reasonable. No big outliers, okay? This is that thing I was showing you, this flow sheet. Flow chart for selecting the appropriate hypothesis test. What type of outcome are you measuring? What's your data? Okay? If you're over here on the parametric side of the house, then you have chi-squares and you're looking at Kruskal, Wallace, and Whitney U. If you have somebody who's reporting that they have parametric data, and then the next thing you see, they're reporting about a Wilcoxon or a Van Whitney U, you know that that data, when they reevaluated it, was now non-parametric, even though they didn't overtly state that. Okay, so this is why we need to understand something about statistics, because sometimes people don't spell out when they're cheating. And I don't mean to say it in a loaded fashion, but when they're manipulating data, they may not be lying, they're just not telling you everything. And you need to be able to read between the lines to see the quality of that article. All right. So this is not meant to insult anybody, anything. Okay, so some of you borrowed this book. This is like, I think, from 2006 or 2008, How to Report Statistics in Medicine. And it kind of spells out, like if you have a correlation study, this is how you write it out. These are the headings they expect. This is the information they want. This is the statistics that should be demonstrated and how you report those statistics in a meaningful way. Okay, very useful. Has a whole bunch of information though about P, right? Using P for significance. The new wave, more and more research on statistics, which sounds wild, but there's a lot of research done on statistics, correct? Really, you find more information with the confidence interval than you do a p-value, okay? A p-value can mean almost anything. You can say it's significant and it can mean almost nothing, okay? And you may not have any kind of clinical correlation with the p-value. Whereas if you look at the confidence interval, you can see a statistical difference that is more likely, you don't always have it, they're not the same, but more likely to result in a clinical significance, okay? So you want to be able to evaluate that confidence interval and not always rely on a p-value. So a lot of people still do research with p-values, but it is definitely shifting now away from p-values. Okay, I know a lot of you have p-values in your studies, so this is probably frustrating. If you read, there's a whole chapter on it in Biddle. I think it's chapter 12. Yeah. Okay. All right. Then what's important is evaluating the power, right, of the study. So if they don't say anything about how they powered their study, are you concerned? It's kind of hard to know what you're evaluating, right? So there should be a little blurb about the power, how they powered their study, how they came to that arrival, right? And then we kind of talked about this already, right? It's expensive. So if it's too big, your population's too large, it's expensive and a lot of resources. But if it's underpowered and you cannot reach a conclusion because you had an inadequate sample size, then you also wasted money and time and resources because it doesn't mean anything, right? It doesn't advance the knowledge at all if it's underpowered because you can't really demonstrate a significant difference. And then if it's overpowered, you can make a false assumption that there's a significance when in reality there's not. It's just that you had such a large population that you were able to see a difference, okay? So you have to power something appropriately. And there's ways to do it. You try to correctly identify that there's a difference between a group and if you can get it powered correctly, you're more likely to have parametric results when you think you're gonna have parametric results, okay? Like, if you overpower it, you may have a lot of outliers. If you underpower it, you might have that peakiness in your kurtosis, okay? The things that are gonna influence your power is your sample size, your alpha level, and your effect size. And there's a process for figuring this out. Do you all feel like you have a good handle on power? Yes, no? Yeah? Okay, all right. I think a lot of people come out of school not really understanding it and feeling like they understand it, and then they start getting into it and they're like, oh, wait a minute. The way they used to power is they would look at old studies, other studies that have done the same, and you still do that. You still need to have another study. If you don't have another study, what can you do?
A pilot or?
A pilot. You can do a pilot study first. If one's not been done, you can do pilot study first, or find a pilot, okay? And you might not find it anywhere but like in a dissertation or in grade literature, okay? Then, or a similar study, very similar study, as similar as possible, okay? They used to use the Cohen's table from 1988, where you looked at this table and it tells you the number you should use. Some people used to say you do like the rules of 30 or 50. For every variable, you need an N of 30 or an N of 50. Okay, that's really a wag though, right? That's really fuzzy. So now they've got this G power, and you can go in and plug in information. What type of statistics are you using, right? Information about population, et cetera, and it helps you to find the power. It's more precise than using the Cohen's table.
Yeah.
And then your alpha level, yes.
In the middle reading
Yes.
for this, talking about power, it seems that you can have a sample that's too big because you might see an effect size that doesn't exist.
Right.
I don't understand how bigger sample isn't better. Because if you see,
Okay.
that was like against everything that we had been taught in statistics, and I didn't understand it.
Yeah. Okay, so did you hear her question that she's talking about the overpowering? Like, how can you actually see something, a false statistical inference, something that's not really there is represented in the data by overpowering? So think of it this way. All right, so emergence delirium, very uncommon. Have to probably have a very large sample size in order to be powered appropriately. Now let's say, what's something more common? Okay, yeah, puking or pain, okay? So post-op nausea or pain. If you have a really big sample, then you're gonna artificially have more information than not. More information that's demonstrating a difference when there's not really a difference because you have such a large sample size. So, okay, let's see, what's another way of describing this?
It seems like,
Let's say, yes?
it seems like when we heard this Dr. Bentley, like we looked at some videos and stuff.
Uh-huh.
And it seemed like on the videos, the more samples they had, the more refined their curves became. Like if you have a small number, like you really have a choppy curve of just individual data points. But when you start to fill in like hundreds, it seems like it gets better.
But it depends on the phenomenon that you're looking at, right? Okay, so let's say, okay, people who've lost somebody to drunk driving, okay? Let's say it's a relatively infrequent event, and you pull a powered sample that's appropriate. It's not underpowered, it's not overpowered. You're likely to get an appropriate sampling of the population. But if you say it's relatively rare, I'm gonna pull 10,000 people. It's gonna look like there's a lot more people who've experienced it than if you had the appropriate sampling.
Aren't you getting closer and closer to the actual number of people that have experienced it though? Like you're getting closer to population size?
You're getting closer to the population size,
Kind of represent the whole population.
but you're representing the whole population because you can't get, so what if you only pulled people from San Antonio, but it was 1,000 versus a place that doesn't have a high population of drunk driving and head versus vehicle or something like that, right? It's not a true sampling of the real population of the United States, but it's a really big sampling in an area that has that problem. And so now you're misrepresenting that information. So you're trying to select so that it represents, your sample is representing the general population. You're not pulling the entire population. That'd be impossible. Nobody has those resources. And so if you power it correctly, you're more likely to capture a sample that is representative of the population rather than capturing everything. It's not helping, is it? I can tell this is not helping.
But just going off that, so you're just saying make sure that it represents the population more appropriately. So if it's, so numbers wise, it doesn't really matter if you have.
But numbers do matter because you can artificially change it by having too many or too little.
So this is just another opportunity to lie with statistics, essentially.
But I mean,
Oh, yeah.
You pair words with numbers.
Any size statistics.
Right. Yeah, with the same
Yeah.
culture, social issues, immigrants, blah, 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 right?
Like the way I'm thinking of it, I mean, if you have a sample of 100 people and you get like 1 out of 100 that has whatever it is you're looking for, and then you sample 1,000 people and you get 10 out of 1,000, it's the same. You still end up with 1%. So I mean,
Yeah, but you're making the assumption. So you hear his explanation? If it's 100 people versus 1,000 and you get 1 versus 10, it's still the same reflection. You're making the assumption there that you're getting equal samples, right? But when you start casting your net too small or too large, your probability of getting a representative population it is altered. Okay? That's not helping either. Go ahead.
So I'm getting that maybe if you pull a lot of people with a certain problem in, say, this area, it might look that most people who end up in a drunk driving accident is because of X, when in fact that's something that happens in San Antonio rather than everywhere.
Right. So some of this has to do with generalizability. So some of this is a generalizability discussion. Can you say something happens in the US when you do it only in one area? Right? But I'll have to think of a better way to describe the power thing. Why you don't want too big versus too small, and why statistically you're more likely to get information that states that there is a clinical difference or that there is a significance when there actually is not, when you're oversampled versus undersampled. Well, or correctly sampled, okay? I'll see if I can find a better description than the way I'm doing it, and I'll bring that for Wednesday or Friday. Wednesday, we may not have time because of the presentations. Okay, let me note that. Oh my gosh, I read too much this weekend. Power. Okay. All right. Okay. I think this kind of plays into it. So with your effect size, when you're powering, if it's too large, there's a greater probability of being able to see a statistical difference that's by chance than you do if you have an appropriate sample size that's been powered correctly, okay? There's more chance that you're gonna have something that says there's a difference when there's really not, okay? Because there's such a large population. I'll get better information for y'all though. So your effect size helps you to see the variance in the dependent variable and your ability to predict that from the independent variable and the difference between groups and association, the strength of those, okay? And a way to figure out effect size is through this website. They have a calculator for it. Just like that G power for the calculation of power. So that is a more specific, more tailored way of having the variables you need to decide on power. Okay, so if your study doesn't explain how they did their power calculation or what their dropout rate was, right? And why did these participants, if you can ever follow up why there was dropout, if they don't say there were 20 dropouts out of 100 because they all died when we gave them this medication, that's pretty significant information. You should probably know that, right? So versus 20 dropped out because we weren't paying a cash incentive and it was a burdensome study. That's totally different, right? Okay. And then if the statistics aren't appropriate for the assertion, if they're using parametric and it's non-parametric data, right? Or like my case, somebody's using some crazy stats you have never heard of, right? Nobody's ever heard of it. There's only 2 articles published on this specific statistical test. Then you should be suspicious or at least be cautious when you're making assertions about this. When you say that total intravenous, remifentanil, propofol, anesthetics decrease emergence delirium, and we should all shift to doing that, right? But they used Jockey's favorite stats, okay? Then you should be cautious about that assertion if you're going to utilize that as part of your database or your information, your background information, your foreground information, okay? So then this is for your presentation. This is the instructions of what I want you guys to address for your stats presentation, which is what? Friday?
Friday.
Okay. If you guys, so in class today, you're gonna take one and just do this part, and then this you're gonna add on to your presentation. If you guys are feeling like you don't have time to do your presentation because you're doing it Wednesday and then again on Friday, let me know. Okay? We can shift, we can be flexible, but I think that for this particular learning assignment versus the presentation, it's building on, right? You're just building on. You should have enough time, but I don't know which other demands are regarding manuscripts mostly, because I know you have fundamentals too still. So if you guys have a concern about that and would like to talk about changing that presentation, let me know, okay? But if we can get it done this week, I would love to do that. And I tried not to make it too many presentations coming too fast, but you still need grades. Yes?
Is this presentation or research statistics, is this about the thing that we were looking up and doing the lit search on, or is this about our research for our
Your benchmark, right? So this, let me clarify that. Today's learning activity and your presentation, you're taking one statistic that you did for your benchmark research that you all conducted, right? And you're stating what statistic you used, what is the relation to your research question, right? Like my research question was blah, blah, blah. I'm looking for a correlation. There's only 2 variables, so I used Pearson's R. okay? That would be the learning activity. Why am I having you all do this?
Because we're gonna get asked
That's
this.
right.
And
Because it's part of your defense, and then you can just rip this slide into your defense, okay? Is that helpful? So it's a twofer, okay? So that's why. And then it's also good exercise in evaluating your research, right? So that you can evaluate future research. Is that? You want me to leave that up? You guys have this slide deck? Everything should be graded up through your learning activities. I think there's only 2 learning activities I didn't grade because they weren't in yet. And you guys, I think, had it set for more time from when I actually checked it. Like I graded before midnight is what I'm saying, okay? Have you all been able to see your feedback, your grades, blah, 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 blah? Yes? Okay. And there's a view button and I thought that I did it appropriately so that you could view everything, but then I got concerned maybe I didn't, so I'm just verifying.
So this week we're doing assignment 5 and assignment 6 this Friday.
Right, so what I'm gonna do, I don't know if, I know what happens when I press escape and I look at the content map with this thing, is it runs away, and I'm not gonna mess with going to the other screen. So, today we did stats instead of the presentation of the systematic search, right? And then Wednesday, we're gonna do presentations of that, and then Friday is gonna be presenting that slide I just had up. And that slide, you're building on 2 extra or 3 extra points from what you're doing in your learning activity today. Okay?
Which name is number 4?
So, the learning activity,
It's number 5.
yeah, let me just go here so I don't. So I'm getting the impression that it would be useful for you all if I went in and put the numbers of the assignments on the content map. Right?
Thanks.
I think so.
So I'll pull this up. So after break, I'll have the assignments folder open, and then I can tell you exactly what number correlates with what. But I think, let's see, we did, what was the first one? The first one, Pico presentation, that's 1 and 2. And then we did search presentation is 4. Then stats learning activity is 5. Stats presentation is 6. Okay? I did that wrong. Pico. I got to do German. Pico. Okay. So the stats presentation is 6. The stats learning activity is 5. And the search presentation is 4. Good? And thank you. And I'll update the content map. And then I'll upload it. So is that going to be too much workload?
Is this for the learning activity that we need to use one of the statistics that we're not using for our presentation? You're talking
Yeah.
about for our presentation on Friday.
It's, yeah, okay, so on the learning activity, I said to use a different stat. Just build on it with the same one, okay? Just build on it with the same one. And then I'll change that for next year. I initially was gonna be all like rigorous with you guys and have you get lots of different experience, but I changed my mind. Okay? Reasonable.
Yes.
How many of you have more than one statistic that you used in your research? Can you raise your hand?
Well, in Like the pig research?
Yeah.
Yes. Okay.
Okay, so now, when they told you what they want for their defense, do they want you all to do all of the stats, present all of the stats that you're using?
Just to-
have that discussion.
You don't, yeah?
We're gonna report to significant notes.
I don't think that we've been given direction about what specific.
Okay.
Maybe some groups have. but
Have you-
No discussion at all.
It depends on your chair. How many of your chairs have told you that they want you to describe more than one of your statistics in your defense? Can you raise your hands if you have?
Well, I'm making an
Describe,
assumption. One,
you know,
just
just
one.
one.
Like,
Okay.
kind of implied.
So it's that, then I'm gonna leave that up to you, okay? If you think it's value added to do one of your stats for your learning activity and then have peer feedback and do another stats that you're gonna have to present in the site, in the presentation, then I don't care if you do two different ones. All it's gonna do is have something done for you that you're gonna have to do anyway. And it just depends if you want feedback on it. Okay? So you guys can choose that. That's up to you all as individual groups. Because I don't know other demands you have on your time right now. It just, if you want to pay now or pay later. Okay? That's how it's all gonna fall out. And you all know you have to defend before you move on to phase 2. So you're gonna have your presentation and your manuscripts, right? And your defense. So it just depends if you want coaching or not. I brought my stats books, okay? This one is awesome. It's more complicated, it's higher level, but it's hilarious. This guy is from Britain and he does all kinds of off-color studies that will make you laugh so that you pay attention, okay? So if you're curious about a statistic that you're using, you're welcome to use this book. I have an older version of this, like a couple years older. I will bring it into the class at break so that we have more than one. This is the down and dirty. This is this test. These are the assumptions that must be met. If not, go to. And I have that flow sheet that I put in that folder for y'all. Okay? And the other thing is this book does the same thing. Where did that go? This book does the same thing with assumptions that have to be met. So, and this you can look like I'm doing a correlational study or I'm doing a difference between group study. And it shows you how to write it up and it tells you the assumptions that need to be met and what statistics are used. Okay? So y'all have resources and I'll let you guys start working and then when you need me, you call me. Okay, same as we've been doing? All right. If you choose to do a different statistic for your presentation, say that up front so I know that that presentation we didn't rehearse together and I can grade it accordingly.